Good day. My name is Hunter Carpenter, Director of Public Policy for the Agricultural Retailers Association. I want to thank you for joining us today for the second in a series of webinars that we're hosting with the Council of Producers and Distributors of Agrotechnology, CPDA. Today's webinar is Adjuvant Advantage for the sales agronomist using oils to protect your chemical investment. The goal of this webinar is to deliver a continued look at the individual categories of adjuvants. This particular webinar will focus on what oils are and what they do as tank mix adjuvants. You will learn about the different types, when to use, and how to optimize performance. Certified crop advisors attending this webinar will earn one Certified Crop Advisor Program IPM CEU. We want to thank you to our program sponsors, Reviton and Precision Laboratories. I will now turn it over to Scott Rollins with CPDA.
Can you hear me now?
Yes.
Okay, sorry. This is Scott Rollins, Director of Governmental Affairs for CPDA. Thank you to ARA for organizing this, and as Hunter said, for our two sponsors, Reviton Herbicide by Helm and Precision Laboratories. I'll turn it back to you, Hunter, or are we ready to go to Johnny Roberts?
Yes, we are. Again, this webinar is being recorded. We will share the recording following. Here's some information about the CEU credits. And here is a brief look at CPDA's advisory working group acknowledgements. We want to thank you again for being involved in this organization and with helping put this webinar together. Johnny Roberts is with us today. He's the Director of Education and Adjuvant Chemistry for CPDA. He's got 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helena Agri Enterprises. Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, or nutritional formulations. Johnny, I will turn it over to you.
Okay, testing on the audio bit. Are we okay?
Yes.
Okay, excellent. Thanks, Hunter, for the introduction. I'm going to be talking today about arguably the most important group of spray adjuvants, and that is the oil-based spray adjuvants. They have both a role in deposition and also a role in enhancing efficacy of pesticides. So in the U.S. market in particular, they tend to be the biggest group and arguably the most important. Next slide, please. So basically what we're going to accomplish in this webinar is to understand why do we even have oil-based adjuvants? What are the different types of them? And then how do we make them mix with water? And this is a role that emulsifiers have, so we'll learn how those function. When do we use them? And then importantly, how do we mix and apply them? Next slide, please. First basic rule to grasp is that we have this rule in organic chemistry that like dissolves like, and it basically means that things that are like water dissolve in water. Things that are like oil dissolve in things that are like oil. The fancy word for that is the lipophilicity, increasing the oil-loving character of a mixture. But it's basically as simple as things that are like oil dissolving things that are like oil. Next slide, please. And you look at what these oil adjuvants do. They modify the lipophilicity of both the active ingredient and the water-based spray that they're being applied with. And the benefits of working in that way are, next slide, several that come to mind. One, recognize that the plant surface that we are targeting is also lipophilic or oil loving, but the water-based sprays that we're applying the pesticide in tend to be lipophobic or oil hating. So you can begin to see there's already a tendency for water to be repelled by these surfaces. And then the other challenge we have is that active ingredients that are not lipophilic, that absorption is slow. And glyphosate is a classic example of that. It is not a lipophilic active ingredient, does not really like oil per se. And so its absorption is slow. Next slide, please. Another benefit that comes from these oil-based sprays, and gets into the role of being a deposition aid, is that they reduce spray deposit evaporation. And the evaporation issue is not only one of concern when the deposit is on the plant surface, but it is also a concern in the carrier itself as it's flying through the air. And that's why historically oil-based adjuvants have been the adjuvant of choice for aerial applications where evaporation of the water carrier is that much more of a concern. Next slide, please. So here's our first challenge. If we're going to mix an oil substance with water, and we think of our rule about how like dissolves in like, well, oil is certainly not like water. So we have a saying in formulation business that gravity always wins. And what we mean by that is that they're going to separate. The oil will rise to the top or sink to the bottom, depending on its gravity, its specific gravity, as opposed to that of water. Next slide, please. So the way that we can compensate for that is with something called an emulsifier. And emulsifiers are a type of surfactant that are able to make very, very small droplets of the oil in water. And by making them so small, then they have the ability to float in that mixture. Next slide, please. And so the benefit of this floating per se is to make a uniform solution from top to bottom. As you can see with the water oil mixture that has no emulsifier, gravity certainly wins. The oil separates, rises to the top. With an emulsion, in this case, what we call a macroemulsion, the particles of oil have been made so small they begin to float. The reason they appear white is that it's a surface that reflects all the light that strikes it. So it has this white appearance. You have another class of emulsion called microemulsions. They're not as common, but they are starting to find application in agriculture, is where the droplets of oil are even smaller than the ones in a macroemulsion, and it gives the appearance of being a solution. The benefit of having these uniform top to bottom mixtures is obvious in the sense that once we apply that spray mixture and separation occurs, we're not getting the intended active ingredient uniformly on that target. And you oftentimes run into the argument, well, I'm under severe agitation. This is not an issue because I'm forcing the water and oil phase together. That is correct. But the minute that spray mixture leaves the spray tank, gravity takes over. Next slide, please. There are essentially three oil types. There are the adjuvants that are based on petroleum oil, and we can further divide them into aromatic and paraffinic oils. There are the crop seed oils, represented by oils that could be anything from cotton to soy to rape to palm. And then we have a more recent group, relatively speaking to the two, called methylated seed oils. We're going to talk about each three groups and what their relevance is to our herbicide and pesticide applications today. Next slide, please. On the petroleum oils, also called paraffinic oils, also called mineral oils, they have been used extensively in agriculture for many, many, many years. And they're unique in the sense that while they have a very important adjuvant role, they're also oftentimes labeled, registered, and used as insecticides and fungicides because they have this role to smother pests. And really what has got them into both roles is that they have this excellent crop environmental and human safety record. You look at the paraffinic minerals, they are essentially what you would find in baby oils and motor oils and so on and so on. They're used extensively because of their low toxicity and human safety. with crop oil concentrates, which many of you know is COC. When you consider that particular adjuvant, it is one of the most widely used spray adjuvants of all with herbicides. Next slide, please. Crop oil concentrate specifically was really one of the first innovations and arguably the first innovation in adjuvants, and that they were introduced in the 60s to basically complement the performance of atrazine. They're still with us today. They're extensively recommended. They're recognized as being an adjuvant, like most all of these oil-based adjuvants are, capable of acting directly on plant surface. And that's important because a lot of the things that you use as adjuvants, for example, the surfactants, are only functioning on the water that's in that spray mixture. These materials, while they do act on the water, they also can act on the plant surface. And the other issue is made them such useful tools is their ability to increase deposition. And so oftentimes we find their use in deposition agents where the intention is simply to get more material on the target and with less evaporation. So they're well established and recognized as having a positive impact on both pesticide application and efficacy. And that's why you'll find numerous pesticide labels recommending them. Next slide, please. The next group is one that is really comparatively quite small, and that's where we're using the crop seed oils directly. Things like soybean oil, canola, rape oil, cotton, sunflower oil. These were looked at extensively in the 80s as an alternative to paraffin oils in order to get a more green, renewable approach, also to utilize oils that come from a material that the farmers themselves produce. And as a general rule, if we build products around them, they typically have performance that's equal to or a little slightly less than that of the petroleum source oils. But unfortunately, they never really caught on to any big degree because they have problems related to mixing, degradation, cost, and some of the antagonisms would cause issues with the foliarly applied post herbicides they were being used with. So really this particular group is not grown that big. It's a small part of the overall group of oil-based adjuvants. They do find some extensive uses with insecticides, some of the other materials that really don't need absorption. They have a good fit there. But overall, this is one of the smallest of the three oil types. Next slide, please. And what came out of the work in essentially the 80s to use crop seed oils is something that we know today as methylated seed oil, or more correctly, I think, esterified seed oil. But in the US, we call them methylated seed oil or MSO. And what this is, it's a version of the crop seed oils, but the issue of their antagonisms and their downsides have been addressed. And they are essentially chemically modified. We would take soybean oil, cottonseed oil, a number of plant seed oils. We chemically modify them through a process called esterification. And we dramatically change their ability to function as an adjuvant. We essentially make their oil solvency better. And in this particular case, and oftentimes, you just hope that when you make one of these moves to increase the sustainability or the greenness, for lack of a better word, oftentimes you sacrifice or not get the same performance as the original petroleum ones. In this particular case, the performance was actually better. And so it is becoming the oil of choice for adjuvants, particularly when they're positioned with herbicides. You're also finding them to be useful in pesticide formulations themselves. In recent years, they've been used for that purpose. A lot of you may not realize this, but essentially they are the type of oil that you know as biodiesel. And that particular use has led them to be a very widely available and a somewhat economical tool for us to use as well. Next slide, please. You can begin to see why these things have taken so much interest worldwide. If you look at the amount of oil that you can extract per given crop, it can be quite extensive, anywhere from 508 gallons of esterified oil from palm to as low as 82 or 26 in the bottom end, but significant. And what you'll find is that the choice, do we use palm oil? Do we use soybean oil? Do we use rape or canola? The origin of that seed crop is not that critical. It doesn't seem to have any effect on the performance. And it's usually a decision based on economics or which particular seed crop is the most available. Next slide, please. Some of the real benefits, what's making this become the oil of choice for adjuvants and pesticides formulations. Excellent petroleum solvent alternative. It is very much a green and renewable material to build things around. It has low flammability, if at all. It has excellent applicator safety, readily biodegradable, and you'll find a lot of academic acceptance and research behind it. There's a lot of manufacturing, basic manufacturers behind it as well. And so you're really beginning to see it used more and more and recommended more and more by the pesticides themselves. There's also been innovations in recent years where they can further modify it by a process we call it ethoxylation, where we can make it even more of basically kind of a cross between a surfactant and an oil and get additional benefits as well. Next slide, please. Here's some pictures that we're going to go into of what makes these materials so potent with herbicides. And this electron micrograph, we're looking at a surface of velvet leaf, and it shows the impact of methylated seed oil that has been applied to that surface. And you can see the effect that it's had on that very, very water phobic surface, literally peeling it back. And the opening that you see below is the stoma of that weed that is under that wax layer. And so now with the presence of the MSO, if you're trying to get material into that plant, it is obviously much easier to do so with the aid of the methylated seed oil. Next slide, please. This slide shows you the impact of a methylated seed oil adjuvant on a herbicide called topramazone. As you can see on my left, you can see the individual particles. We're looking at velvet leaf again on the outside of that leaf surface. If we add the methylated seed oil, we see some obvious distortions in the plant surface, but even more significant, we see the particles not visible on that surface, indicating they've been absorbed. And it's interesting, oftentimes if you wait long enough, those particles would move in without the help of the MSO, but the difference is much more slowly. And speed of absorption is very important. That is the property that makes these materials rain fast, that speeds up their action, gives the biological effect that we want. So speed is very much a positive thing when we use adjuvants with herbicides, and like in this case. Next slide, please. Okay, and here's where we get into an important concept, and I mentioned to you how oil-based adjuvants are generally recommended on a per acre basis. And what you'll find for both crop oil concentrates and methylated seed oils, there's 1 to 4 pints per acre. 2 pints is typical. With your methylated seed oil, there tends to be a generalization of we need a pint per acre. And essentially, that's where the world has been for quite a while. And what is happened, and basically out of need and to sort out confusion, is also there is a per volume recommendation. And what we mean by that, instead of saying use 1 to 4 pints per acre, we're going to use 1% by volume. Now, the way that would work out, we're using 1 gallon of the oil product in 100 gallons of water, and we get that 1%. And as you can see, I mean, depending on how much of that 100-gallon spray mix we use will determine how much of the oil we deliver per acre. You know, typically when we add a gallon into 100, we're essentially adding 128 ounces. And if we divide that by the 100 gallons, we're roughly getting 1.3 ounces of oil per gallon of water we apply. And some of these 1% by volume recommendations were based back in the days when spray application volumes were much higher compared to what we do today. They were averaging 25 to 50. Today we're 15, sometimes as low as 10. So we have to be aware of that, in the sense that if our spray volume gets below 15 GPA, we need to do the math and see if we are delivering the amount per acre. And this is something that the herbicide manufacturer can give you some direction on, as well as direction on when do I use and at what particular rate an MSO versus a COC versus an HSOC, a group that we're going to talk about in more detail here shortly. But we're going to visit some labels because they are always, in the case of adjuvants, our guide into the type, how much we should use, and even when we should use them. And fortunately, what you'll find with herbicide labels, they are by far the most advanced in telling you the type of adjuvant to use. However, there are still some things to be aware of and some questions that you may need to ask when you make that application or that recommendation. Next slide, please. Here we're looking at a clethodim herbicide label recommendation. And clethodim is a herbicide type across brands, has an adjuvant recommendation. It's not a suggestion, it's actually a recommendation that you use one. And we'll show you some examples of some are outright requirements, because we're getting into areas where the adjuvant is crucial to getting the effect that we're trying to get out of the herbicide. Now, you'll notice in this recommendation, they're telling you that you can use either a crop oil concentrate or a methylated seed oil at 1 quart per acre or 1% by volume. And what you'll find is that if your spray applications are per volume are up in that 25, 50 gallon, 30 gallon per acre range, that's more than enough if you're using 1% by volume. If you're going less than that, getting into spray application volumes less than 15, you may not be reaching that 1 quart per acre. So again, that is something that you can ask clarification from the herbicide producer. When I go down in the spray application volumes per acre, do I have to increase or use a higher rate of the adjuvant the other way? Next slide, please. Okay, this is for a herbicide called branded Caprino from Bayer. And I like this one from the standpoint of how it puts on the label itself a lot of the things that we're going to talk about in this webinar and talk about their importance. Notice when you get into spray additives, we've got the very strong word requires the use of an external adjuvant. And external adjuvant is just another name for, a lot of herbicides have adjuvants built into them. When they say we're adding an external adjuvant, that's just another term for the adjuvant that's being added tank side. So this thing, it requires it. And this is one of those things that with a lot of adjuvant applications, you're just getting into their use as insurance. They're used to add a little bit extra boost. And many of these herbicides, you could have failures if we don't use the right adjuvant or don't include one. So that's the first point. This particular herbicide requires it. And you'll notice when you go to their specific recommendations, they're saying a crop oil concentrate of 1 gallon per 100, that's 1% by volume, should be used. So that's pretty straightforward. They don't have a per acre use rate. But they're saying, and they're further defining what that crop oil concentrate should be. they're saying that it should be at least 80% crop oil and at least 10% emulsifier or greater. That fits into the basic definition of crop oil concentrates, but be aware oftentimes on adjuvant labels, this is not clearly defined, the amount of oil, the amount of emulsifier. These are questions that you should ask that manufacturer. With CPDA certified adjuvants, where the labels have been through a review, those follow ASTM definitions for that. So that's at least an amount of a concern, but when they're not, that is certainly a question that you need to ask. The other point they make here is they talk about a group of oil adjuvants called HSOCs, or high surfactant oil concentrates, that we'll talk about in a bit more detail. And they're telling you that they may be substituted for the addition of CLC. And you'll find that those materials have lower rates than traditional CLCs. And again, refer to the labels for your manufacturers for the guide there. With MSO, notice that they're giving you that alternative, but they have significantly dropped the amount that they're recommending, only 0.5% by volume. And this reflects the extra potency of MSO. And they're particularly recommending it when growing conditions are adverse, drought stress, low humidity, etc. That's where the really high performance, high degree of solvency of an MSO can come into play. Next slide, please. This is an example of an MSO specific herbicide label. The active ingredient is saflufenicil. The branded herbicide is Sharpen, and they're telling you the adjuvant is required. I mean, this is one of those that if it's not applied to the adjuvant, it may fail. It will not deliver what the weed control is expected. They're specifying MSO. Notice they're not really giving you an option for anything else. They're not giving you an option for a CLC. They're not giving you an option for NIS, or saying an MSO. And what is interesting, they're even specifying the amount of MSO that should be in the adjuvant. And specifically, they're saying 60%. And again, this is something that you can't readily tell from most adjuvant labels. It's a question you should ask if you're considering a specific sort of an MSO adjuvant. For a Sharpen application, they're putting the burden on you as the applicator to ensure that that MSO is at a certain minimal level. Another thing that's noteworthy, notice they have a warning: do not substitute non-ionic surfactants for the MSO. And this is another common mistake. Some applicators, many growers, assume that all these adjuvants are the same. There could be quite a difference in activity from a non-ionic surfactant and MSO. I recall from other training that you've had, surfactants impact the water, oils impact the plant surface, so you can see they can be quite different. Next slide, please. Another thing to be aware of, and particularly when you're considering oil-based adjuvants for other things like fungicides and insecticides, where you don't really have the guidance about adjuvants on those labels like you do on herbicide, is that often the labels imply the use of an adjuvant. You know, if you're reading that label and you see terms like avoid off-target drift, and thorough spray coverage is important, and coverage should be maximized. You know, these are implied recommendations that an adjuvant may have a role in improving all those. And in particular, you get into that deposition function, and it's really difficult to argue that there's no pesticide spray that wouldn't benefit from enhanced deposition, and oil-based adjuvants have a role in that, and a role in providing that. So be aware of that. Oftentimes label language implies an adjuvant use without recommending one specifically. Next slide, please. What we always like to point out people when we get into this the group of and understanding how adjuvants work, you can essentially divide them into this very, very broad category of those that are surfactants and those that are oils. Growers tend to understand them that way. Many applicators do, and they know that, well, when I have a surfactant, I get better spreading, coverage, and wetting. Also get a little bit foaming with that. I know that my driftwood fines, they don't really have an impact that's positive on the formation or not formation of driftwood fines. I know that my evaporation can be actually worse if I have surfactants that spread out the material to such a point in a low volume of water. I certainly increase their evaporation. And so I have my oil products that I can fall back upon, and yeah, they have a little less spreading and wetting. They have less foaming, which is great and is positive, and they have less evaporation. But we've always had this dilemma of either or, and when do I recommend one? And typically you get into these deals where surfactants are recommended in the spring and oils are recommended in the summer. Surfactants go out by ground and oils go out by air. As you can see, a lot of confusion can come into play, and that's resulted in the development of a type of adjuvant where you combine the properties of both. Next slide, please. And the category that has really come out of this, and it's kind of an interesting when you think about it, it was the adjuvant industry that essentially created what is known today as a high surfactant oil concentrate, or HSOC. And it's defined by the ASTM as an emulsifiable oil containing 25 to 50% of the surfactant and a minimum of 50% oil. And what's significant there, by increasing that surfactant load, they can make the oil-based adjuvant have more wetting and spreading properties. And this sort of allows the grower and applicator to use adjuvants that can go both ways. Split the difference between the two. Next slide, please. Some notes about using them. Understand that HSOCs, they're just starting to get more label recommendations. Some are based around paraffin, some are based around methylated seed oil. Methylated seed oil is becoming somewhat preferred because the generally lower use rates you're recommending these adjuvants at, you need a little bit more of that potency, and also recognition that when you have drought and heat stress involved, it's difficult to outperform or be better than an MSO. Use rate range is lower than what you'll find for traditional oil-based products, as low as 0.5% by volume, which is 2 quarts and 100 gallons of water. Be aware that your label guidance on these, you often have to fall back on the manufacturer or the pesticide manufacturer, but I think you'll see this get better as this particular group gets more acceptance because they are such problem solvers. Another, and we're going to talk about spray mix compatibility toward the end here, but they tend to be much easier to use and avoid particular problems that are related when oils are not mixed properly with pesticides. They tend to be easier to use from that standpoint. So best way to understand an HSOC is that they just split the difference. They're sort of this in between a surfactant and an oil-based adjuvant. Next slide, please. This becomes important in the sense of there's some rules when we mix oil-based adjuvants into spray mixes. And, you know, with the surfactants, they tend to be a lot more forgiving, not so much so with oil-based adjuvants. There are some rules about how we mix it and apply them. The biggest rule is that we never mix them directly with undiluted pesticides. As you can imagine, if I take an oil and I mix a dry pesticide or one of the suspension concentrate type materials directly with that oil, I can create a number of problems of undispersed product, clabber. There's some real descriptive terms out there, mayonnaise. So we never mix them directly. And as a general rule, unless the label of that adjuvant tells you differently, they are the last component added. And that makes sense. I mean, you've got to get everything mixed before you add an oil to it. And more, we're getting into the need to combine pesticide sprays and the adjuvants that come with them, along with fertilizers, all at the same time to save a trip through the field, get general efficiency better. The challenge there is, think about our gravity issue. Now, instead of water, we're a fertilizer. And so these separation issues are magnified. So there's some general rules when we do mix with fertilizers. One's, it is worth the time to conduct a simple jar test to make sure they're compatible if the manufacturer can't tell you that status. One way to make fertilizers mix better or easier with oil-based products is simply dilute them with some level of water. So it are compatible, some more so than others, but it is something that you need to be aware of in preparing those mixtures, especially if there's no water in them. Another thing to be aware of that with sulfonylurea herbicides, and we know that these materials, cleaning them out of a tank is very, very critical, very important. Oil-based adjuvants can make that clean out more of a challenge. They leave the oily residue on the sides of that tank and the hose. The herbicide residues are retained behind. Not a big issue as long as you're doing proper cleaning and using an effective tank cleaner, but just something that be aware of compared to surfactant-based products. The oil-based adjuvants are much more critical that you clean those systems than it is with the surfactant ones. And of course, with fertilizer, remember we're fighting gravity, and agitation must be maintained while you're making that application. If you turn off that agitator, and even with the best emulsion system out there, it's going to eventually separate. It's just the gravity is too much to ask those things to stay together. There's also an issue of crop injury potential. Next slide, please. As you notice this particular slide, as you move toward my left, an aromatic solvent in this case, there's a sense of scorch or burning from using these oil-based materials. Now, understand, the oil-based materials themselves are quite benign, other than the aromatic solvents, they can't really cause any direct injury. But if that particular spray mix is already problematic, if there's been a history of this herbicide alone being marginally safe, adding an oil-based adjuvant to it could make that more of an issue. So there is a general ranking. If you're trying to avoid crop injury completely, or make it at least of concern, the paraffin and seed oils tend to be milder than the methylated seed oils, but understand that comes at the cost of performance. The absorption is less, but it is also less hot. So it's something to be aware of. Past commercial history is a good guide there. Many labels will guide you on that. But there is a relationship between the oil, as it is more of a solvent, it becomes that much more likely to cause some kind of crop injury. Next slide, please. So what we always like to do on these seminars is to go over, well, from the customer's perspective, what's the customer's objection to using these oil-based adjuvants? And one, and you often run into this, is that, look, I've got my handy non-ionic surfactant that I'm using routinely. I can use these all the same way. I'm going to use a surfactant instead of an oil, and because I don't want to carry two products, and it's just simpler. And the point there is that surfactants oftentimes lack the ability to enhance absorption, which is the actual goal of the adjuvant, and then the labels themselves do not permit their use. Sometimes you have either or. You can use a surfactant or an oil-based material, but be aware, in most cases, the use rate recommendations are different. But there are plenty of times, several times, many times, where you do not use a surfactant as a replacement for an oil. Next slide, please. Well, what if the label, excuse me, I got ahead of myself. I'll go backwards again. Okay. What if the label does not recommend them? And as I mentioned before, oftentimes the labels imply them. Improved deposition is always a need, and that's what an oil product can do. Also, the point that, hey, this oil adjuvants, it doesn't cover as well as my surfactants. I can't use it with things like glyphosate. I can't use it with things that are systemic, and that is correct. That is a legitimate concern. But recognize that many oil adjuvants with higher loads of surfactant, the HSOC materials, can address this limitation. And then the other issue, and this is a common one, I had trouble last year. I'm not going to use them again. They're just too difficult. The reality is that following the proper mixing order and managing it that way, they're actually no more difficult to use than surfactants. It's just there are rules that you have to follow. And when in doubt, always do a jar test. Now we'll do the last slide. So the bottom line is, and this is what we want to stress and leave you with, is that oil-based adjuvants are an essential part of that spray program, and it's just as essential as the pesticide itself. And yes, it can be complex and it can be confusing, but that's getting better. And one of your roles as an agronomist, as a technician in the field, is to help clear up that confusion and get through it. And it's just critical to recognize that these are just as important part as the pesticide itself. Next slide, please. So we want to finish up by thanking our sponsors once again. They make these presentations possible, and also appreciation to the people among the board that have helped us review these presentations and have made them quite useful, we feel, for the people that use these products. So, questions and answers.
And Johnny, I'm just reading from the Q&A here. One person asked, can you provide a list of references for some of the data that you shared with us today?
Ooh, yeah, there's, yes, we could. There's some of probably the biggest body of data that we leverage off of is actually back in the 90s. If you go back to the original work that was coming out of North Dakota State University with MSOs, that's where that particular technology was found and innovated and explored. That's where I leverage a lot of information from, what we've used in training. You'll find a lot of papers published by Dr. John Nalawai. In fact, if you really want to get into the background of these methylated seed oils, just research anything under his name and you'll find a very long list of references and work that supports it.
Next question, what would happen if you used a paraffinic oil instead of an MSO with a herbicide like Sharpen?
Okay, that is a good question, and that is a good example of where the paraffin is just not as effective. There are people that have used it as a replacement. It will work to some degree, but not to provide the performance that's expected. And it's interesting. I would think the real reason that it doesn't work as well is that it's lack of solvency. It's not a good solvent. An MSO is. And it is getting past that barrier, that plant barrier, better than what a crop oil concentrate is. So you're really not given a choice with that particular chemistry. It's MSO or and not the paraffin oil at all for that reason.
Next question, is there a need or advantage to use different oils to penetrate different leaf surfaces?
Yes, there are. And one of you look at the future of adjuvant development, adjuvant research. To be quite honest, there have been too much of use of chemists and not enough of biologists, and that's difficult for me to say because I'm a chemist. But if you look at how a lot of these adjuvants were developed, it was around paraffin, it was around wax surfaces that we can control and measure and keep consistent. But in the real world and where the biology is, those surfaces can be quite different. And there are some weed surfaces that are actually hydrophilic. They like water. And so as you can imagine, performances are different. So yes, there's great research opportunities to custom tailor formulations to fit specific weed surfaces. We know that it's a need. The industry knows it's a need. I think you'll see more of that as time goes on, because we're getting to such specific problems like amaranth and like lamb's quarter. I mean, you can make the argument that you should be tailor making some of these oil-based systems for those weed surfaces alone. But for now, the general use of adjuvants is to be general. And, you'll see most of the recommendations are very wide, and they're picked so that we don't have to inventory basically an adjuvant for each weed. We certainly wouldn't want to do that. But I think the answering those questions is some great opportunities if we're able to, and do custom tailor adjuvants that match those particular services.
Next question, are there concerns with MSO antagonism when mixed with glyphosate? And if so, what's recommended when mixing glyphosate with a lipophilic herbicide?
Yes, and that, it's interesting. MSO, oil-based adjuvants mixed with glyphosate are not good. I mean, if you go back and look at the history of it, you'll see labels recommending against it, not to use crop oil concentrates, not to use methylated seed oils, use non-ionic surfactants instead, because it is a very hydrophilic substance. And all that began to change when we learned how to make oil-based products with surfactant properties. And, that's one of the real tests of an HSOC. If you take a traditional MSO only with glyphosate and you compare that to the performance of an HSOC with glyphosate, the former will not work as well as the latter. And so you can modify oils to work and not antagonize glyphosate, but it has to be done with something that enhances its ability to wet and spread and add coverage, not just absorption, with that particular use.
Next question, aerial applicators say that they hate to use MSOs and mixtures because of potential drift issues. Is this true or just an old wives' tale?
Yeah, I would, they're generalizing. They may have had the misfortune of getting a product that was more surfactant than oil. I could see that possibly causing more drift, but oils as a good general rule do not increase the chance for spray drift. They in fact reduce it or have less tendency to form it. So I would guess in that particular situation, someone got a product that was more of a surfactant than an oil.
Another question, are there any resources or textbooks you would recommend for new members to the industry to have as a reference on adjuvants overall?
Ooh, that's a good question. And unfortunately, there's not a lot of them out there. You'll find that there's some great academic papers. Purdue has some excellent bulletins, extension bulletins on adjuvants. That's the one that I would recommend specifically. There's some other extension publications out of NDSU that are excellent, that will provide you insight and to be frank, I leveraged against a lot of those in putting this presentation together. So they're out there, but as far as just one textbook per se, I don't really think that exists, but you will find some good support material out there from extension services.
Last call for Q&A. I want to once again thank Johnny for joining us today, and this is a very enlightening, helpful presentation. We certainly want to thank CPDA and their board, as well as Reviton and Precision Laboratories for sponsoring. We do have the ability for folks to grab CEU credits here. You can scan the QR code with your mobile device to receive those CEUs. If you are attending from California, we do have a quiz put together for you to follow up as required by those state regulations, but please email info@cpda.com to obtain this quiz. Again, thank you. Huge thanks to all of the attendees and of course our sponsors. And this recording will be made available on aradc.org. That's the Agricultural Retailers Association's website under resources and webinars, as well as some of our past webinars that we've had with CPDA and future. We've got a number of different webinar topics surrounding adjuvants that we will be presenting February 16th, surfactants, stickers, and silicones, March 16th, water conditioners, and April 13th, drift and deposition. So lots of great information provided by Johnny and Terry Kipley and the folks at CPDA. We want to thank you again for joining us today. And if you have any questions regarding how you can access that webinar, please contact me, hunter@aradc.org. We want to thank you again for attending. Have a great day.